Alright, today we're going to talk about naming ionic compounds. And so I'm going to move through this list of rules fairly quickly. You can pause the video at any point in time to catch up. So the first rule is you name the cation, and cations are the positively charged ions. If it's a transition metal like iron, you'll put its oxidation number in parentheses. If it is bonded to just a normal element, you'll change the ending to "-ide". Remember that "-ide" is the ending for elements at the end of ionic and covalent compounds. And if it's bonded to a polyatomic ion, you just name the polyatomic ion. Remember that the positively charged ion can be a metal or a positively charged polyatomic. There are only two positively charged polyatomics we've talked about, so it'll either be ammonium or hydronium if it's going to start an ionic compound. And then the endings will be nonmetals or negatively charged polyatomic ions. If it is a nonmetal, you'll change the ending to "-ide". If it ends in a negative polyatomic ion, you just name the polyatomic. So we'll start with an example here, NaCl. Na is our metal, it's our cation, and so we just name the cation. So Na on the periodic table is sodium. Oops, a daisy. So we name it sodium. Cl is next. It is our negatively charged ion. It is a nonmetal. And so we'll change its ending to "-ide". So rather than chlorine, we will get chloride for sodium chloride. Alright, next ones will be a little more complicated. We'll use transition metals. And remember that if it is a transition metal, you'll put its oxidation number in parentheses. And we'll have to calculate its oxidation number. You won't be able to look at the periodic table and know. Alright, so we have FeCl3. We'll start off by identifying our positively charged cation. That's iron. And iron is a transition metal, so we will need some parentheses for iron. We need to figure out what charge that iron is going to be. The way we figure out the charge of our iron is by figuring out the charge of our negatively charged anion. So here we have chlorine. Chlorine, if you look on the periodic table, wants to gain one electron to be a noble gas configuration. If you gain one electron, you are -1. So chlorine has a -1 charge. But we have 3 chlorines. So 3 times that -1 is a -3 overall. The only way you cancel out -3 is with +3. So it must be iron 3 chloride. Next one, not a polyatomic, not a transition metal. So we'll just look at it and we'll say that Li is lithium. So we write lithium. And then we have a polyatomic ion, PO4. PO4 is the polyatomic ion phosphate. Because it's a polyatomic ion, there's no need to change the name. So we just call it lithium phosphate. We can check to make sure the charges work out nicely. Phosphate has a -3 charge. Lithium is in group 1, so it has a +1 charge. That's why we need 3 lithiums, so that it's +3 overall to cancel out our phosphate. Alright, one last problem, or several more problems really. We're going to erase these and write some problems of our own. And so, the first problem we're going to have, we're going to figure out what SN3 PO4's name is. So SN3 PO4 4. The first thing we'll need to do is figure out what that positively charged cation is. Sn, if we look at the periodic table, is tin. It's element number 50. And so then what we have to do next is decide whether tin is a transition metal. Technically it's in this no man's land, often referred to as post-transition metals, but we treat it the same way. So, tin is a transition metal. We will need parentheses to tell us what charge that tin is. And then we need to remember what PO4 is. To my favorite polyatomic ion, it is phosphate. Because it's a polyatomic ion, no need to change the name, so phosphate it is. But now we need to figure out the charge of that tin. We do that by remembering the charge of phosphate. Phosphate is always -3. So now we have this 4 on the outside here times -3 to give us -12 overall. So that was the charge of phosphate times how many phosphates we have equals -12. And there is only one way to cancel out -12. That is with a +12. So all of the tins must multiply to be +12. So then the question becomes 3 times what number equals +12? And that number must be 4. So we have tin 4 phosphate. Alright, another problem could be this. F-E-N. I'm going to write 3 more problems. I'd like you to attempt to solve them on your own and then come back here and we'll solve them together. Alright, and then we have COCl2, and we will also have Ca3PO4 2. Alright, so take a moment to name those. Pause the video because I'm going to start naming them right now. So as we look at this first example, we'll call this number 1. Fe, we know that one well, that is iron. Iron is in fact a transition metal, so we will open up some parentheses. And now we need to name our N. Well, N is not a polyatomic ion, it is nitrogen, but we always change the ending to "ide" when it is just an element. So the next course of action will be to look at nitrogen. Nitrogen is 3 spaces away to having a noble gas configuration. It wants to gain 3 electrons. If you gain 3 electrons, you become 3 negative. There's only one way in the world to cancel out a 3 negative. It is with a 3 positive. So this must be iron 3 nitride. Next up, we have our number 2, which is COCl2. As we look at the periodic table, we find that CO is cobalt. Cobalt is also a transition metal, so we will need parentheses. And then we look at Cl. Cl is chlorine, but you can't have chlorine, so we change the ending to "ide" and we have chloride. Now chlorine only wants to gain 1 electron to have the same electron configuration as argon, a noble gas. If it gains 1 electron, it must be a -1. But we have 2 chlorines. So now we have 2 times a -1 equals -2. Only one way to cancel out -2, that is with a +2. So cobalt must be cobalt 2 chloride. Last one, call it number 3. We got Ca3PO4 2. As we look at the periodic table, we find that Ca is in group 2, it's element number 20, it's calcium. Calcium is not a transition metal, so there is no need for parentheses. So then we just name our polyatomic ion. Good old phosphate. Calcium phosphate is the final answer. Now we can check our work just to make sure the charge of calcium should be what it is, just to make sure this is in fact a stable molecule. Calcium is in group 2. Group 2 elements are always 2 positive. We have 3 calciums, so that must be 6 positive overall. So we need to make sure that these 2 phosphates are 6 negative. Well, fortunately we know that phosphate is always 3 negative. 2 times that 3 negative equals 6 negative. Cancels out nicely. So calcium phosphate, final answer. Come in if you have any questions.